This is Team E's analysis of New York City restaurant inspection results using IBM Watson. For our investigation, we are using data provided by the Department of Health and Mental Hygiene that was collected as the result of restaurant inspections. Over 30,000 restaurants were inspected, and there are over 400,000 records. This gives us a very broad data set to develop findings. We are able to consider a variety of factors, including restaurant location, which includes addresses, zip codes, and boroughs. Cuisine type, categorizing restaurants into 85 different cuisines. The date restaurant was graded, and inspection information, which covers violation, critical flags, total score, grade, and the type of inspection conducted. With this large population and collection of attributes, we hope to find interesting correlations that will tell us more about the New York City restaurant industry. After we imported the data, we elected to come up with our own questions for Watson. First, we are curious to know what the most common violations are. Second, we would like to gain a general idea of how critical the violations for the New York City restaurants are. Finally, we would like to see if there are any correlation between cuisine types and violations. To get answers to these questions, the necessary measures we will need to include are a summary of the violation types and critical level, and the relationship between cuisine types and violation types. We asked Watson for the most common violation descriptions and received this chart that you see on the slide. The chart shows the distribution of violation descriptions for the restaurants inspected. From the chart, we learn that the top violation in the restaurants in use is an unacceptable material for a non-food contact service or service isn't properly constructed. Non-food contact surfaces or equipment are improperly maintained, sealed, raised, spaced, or movable to allow for accessibility of cleaning on all sides, above, and underneath the unit. This type of violation hit over 55,000 records. The second most common violation, which will be more familiar to most people, is the evidence of mice or live mice present. It is a serious hygiene problem for restaurants, and it is surprising that over 40,000 examples of this violation exist in the dataset. The third most common violation was for food that was not protected from a potential source of contamination during storage. There was close to 28,000 instances of this violation. The findings will be helpful to restaurant customers, government regulators, and restaurant owners. For customers, after learning about the findings, some of the local residents may want to cook more by themselves to have cleaner food. For tourists, they will be prepared about the potential problems. For regulators, such as the Department of Health and Mental Hygiene, they can learn about what aspects they should target to regulate restaurants and urge them to improve. For restaurant owners, they can learn more about their industry trends and situations, benchmarking the environmental conditions of their own restaurants. We asked Watson for the distribution of critical flags in the dataset. It generated a chart which compares the number of rows of the critical flag column. For this chart, we have learned that close to 2,200,000 of the violation records are critical violations, which is greater than half of all the violations in the record. We dug a bit deeper into the data by making a pivot table in Excel. We used critical flags and boroughs as the rows, sum of numbers of rows as the columns, and a cuisine description as the filter. It tells us that the restaurants in Manhattan had 87,000 records of critical violations, the highest among all the boroughs. It is 61% more than that of Brooklyn and 73% more than that of Queens. But the total number of violations records in Brooklyn and Queens is still more than that in Manhattan. As we use the filter in the live table, we will also be able to see the critical distribution of different cuisines in each borough. When analyzing the findings, one must recognize that there are also many more restaurants in Manhattan than other boroughs. The findings can be an alert to all customers, regulators, and restaurant owners who want to be aware of critical violations. For customers, especially after they incorporate down to their local zip code, local residents can have a better idea about the hygiene conditions of their area. Government regulators can measure the amount of manpower in each borough and execute different frequency of the inspections according to the critical violations. It is also good information to restaurant owners to have some idea about the local businesses that they are competing against. Finally, we set out to investigate if certain cuisine types were more prone to violations, or certain types of violations. It appears that American cuisine followed by Latin reported the most violations, but Watson was unable to take into account the number of restaurants in each category, making it difficult to determine whether this finding is accurate per capita. This finding could benefit different cuisine restaurant owners to pay attention to the violations that they are more easy to make. And it would also provide general idea for the inspectors that which violations are more easy to be found in which types of restaurants. According to the data generated by Watson, it is not hard to tell that American cuisine restaurants have the highest number of violations. Chinese comes in second and Latin comes in third. As previously mentioned, Watson cannot finesse the data into a per capita breakdown, so it is hard to view this as actionable data. However, we can use this data to see that these cuisines are violating the same health codes. From this perspective, it seems there is no correlation between restaurant violations and cuisine type. This exercise proved that Watson Analytics is a powerful tool that can be used to draw meaning from data. With that being said, Watson is a machine and not all the findings provided were relevant or made sense to the purpose of our analysis. While Watson is a proven tool for artificial intelligence, it appears that it is not yet able to fully replace humans in decision making.